Okay, you can see that I've chosen not to do a paragraph proof, but instead do a two-column proof. I'm going to start by rewriting my given. So for number 1, in triangle ABC, AD bisects angle BAC. So given, all right. Notice that they've hinted that we draw an auxiliary line BX. So we're saying BX is going to be parallel to AD. All right, so I'm just going to add that little notation there so you can visualize that. So that's going to be our second point, and that is to draw BX parallel to AD. And we'll just say, we can say 2 points determine a line. 2 points determine a line. And could also say draw parallel line as our reason there. Okay. Number 3. Well, let's take a look now at what we're trying to prove. We want to prove that BD is proportional to DC as AB is proportional to AC. Well, you've used this plenty of times. So BD is proportional to DC as AB is proportional to AC. Okay? So how in the world are we going to go down this path of proving? Well, the first thing I'm going to do is rename some of my angles just to make it a little easier for us. I'm going to call this angle 1. This little angle right here is going to be angle 1. The one that's congruent to it right beside it is going to be angle 2. Oh, that's hard to see. This is angle 2. And then this one up here is going to be angle 3. Equally hard to see. Angle 3. And then this one down here is going to be angle 4. I hope you can read all of that. All right. So we know then that if these are parallel lines, if those two red lines are parallel, then we can state that angle 1 and angle 3 are congruent to one another. Angle 1 is congruent to angle 3 because they're corresponding angles, okay? Corresponding angles are congruent, all right? We can also say that angle 2 and angle 4 are congruent to one another. Now I'm just going to extend this line a little bit. Angle 2 and angle 4, this line right here is like a transversal. So angle 2 and angle 4 are alternate interior angles. Now I'll erase that so that we can actually see what's going on here. But I hope that you can see why I can say that angle 2 is congruent to angle 4 by alternate interior angles. Alternate interior angles are congruent. Again, we're just using that idea that our two red lines are parallel to one another. Okay, so now what we want here is we're going somewhere with this, okay? We're going to be able to use the transitive property here, but now that we know that we already knew that angle 1 and angle 2 were congruent to each other. That was given to us, okay? We know that we've stated that angle 1 and 3 are congruent. So let's go ahead and just mark this. We know 1 and 2 are congruent to one another. We know, maybe make this black. We know 1 and 2, and we know that 1 and 3 are congruent to each other. So we can state now that angle 3 and angle 4 are congruent to each other. Angle 3 is congruent to angle 4 by the transitive property. Okay, now probably up here we should state that angle 1 is congruent to angle 2 that was given to us, because essentially what we're doing is we're saying we're going from angle 4 to angle 2 to angle 2 to angle 1 to angle 1 to angle 3. So that's how we're saying that angle 4 and angle 3 are congruent to each other. So we use the transitive property multiple times to get from angle 3 is congruent to angle 4. So transitive property of congruence here, all right? So if angle 3 and angle 4 are congruent to each other, let's go ahead and mark that. Now, do you see that we have an isosceles triangle? That means, people, that AB and AX have to be congruent to one another. Okay, AB and AX, that's these right here. Okay, so let's state that. That means that AX is congruent to AB. AX is congruent to AB by the isosceles triangle theorem, okay? Now, number 7 is going to let us make some other statements. We're gonna say, we're gonna write some proportions here, okay? The and the reason is gonna be the triangle proportion, triangle proportions theorem, okay? We're gonna say, and I'm gonna just color code these here so you can see them. We're gonna say that BD is to CD as XA is to AC. All right, now what I want you to see is this whole thing is a triangle, okay? So this big section right here, okay, so BD is to DC as XA is to AC. So it's like we've got this little piece, and then this piece right here is to this little piece as this piece is right here. Do you see all of that? I'll erase some of that so it doesn't look so messy, but I wanted you to see where we were going with that, okay? So, and that's going to be the triangle proportion theorem. BD is to CD as XA is to AC, okay? Now that whole idea there also has to do with that mid-segment theorem, right? Okay, so not the mid-segment theorem, but the idea that if this line is parallel to this one here, then these sides creates two proportional triangles. Okay. So if you need some more clarification on that one, I'll be glad to help you with that. Now, let's go to number 8, which I think is going to be our final step, because we can say that BD is to CD. I'm just recopying this, right? Okay, but a second ago, we said that AX is congruent to AB. Well, look at this. Look at this one up here. This is almost exactly where we were wanting to go. We have AC. The only thing we need here is AB instead of AX. Well, we've got it right there. So we can say that AB goes here, and the reason is by substitution.